Welcome to the Slop Temple. We pray this video helps.
You need to understand lenses before any hands-on attempt. Focus on safety first. A convex lens bends parallel rays toward a focal point. This concentrates energy, which explains heating effects. Once you grasp that concept, make sure to avoid experiments near flammable materials and never point concentrated light at people or animals. Protect your eyes and have water nearby. I will explain physical principles, what to observe from a distance, and why supervision and controls matter to prevent accidental fires and injuries. You can visualize how focus alters energy without performing risky steps. When parallel rays converge, the spot size dictates energy density, so smaller spots yield higher temperature potential. Once you understand that, observe safe demonstrations. Use infrared-sensitive cards or temperature sensors at varying distances and compare materials that absorb or reflect differently. Make sure to conduct any observation under controlled, supervised conditions and use non-flammable targets, so you learn the relationship between distance, spot size, and heating without creating. You should rely on safe methods to study concentrated light effects rather than starting a fire. Use indirect tools, IR thermometers, thermochromic indicators, or ray tracing software to quantify heating and visualize focal behavior. Once you set up these alternatives, monitor for harmless signs like gentle warming or color change. Stop immediately at any sign of smoke or charring. Make sure to have emergency controls ready: water, fire extinguisher, and adult assistance. And if heat becomes uncontrolled, prioritize evacuation and emergency services.
Thanks for watching. Consider subscribing if we helped you.